Good afternoon and salam sejahtera to Dr. Siti Razia. Today, me and my partner Celestia Pina would like to present about our project proposal. So, we both chose Laplace transform as our project proposal. Let's begin, shall we? What is Laplace transform? Laplace transform is an integral transform that converts a function of a real variable t, often time, to a function of a complex variable s, complex frequency. It provides a useful method of solving certain types of differential equations when certain initial conditions are given, especially when the initial values are zero. This transform has many applications, especially in science and engineering because it is used for solving differential problems. Besides that, these Laplace transforms are very useful mostly in electrical engineering, which in the area of circuit analysis. Basically, we would like to choose this Laplace transform as our project because we want to help any engineering students calculate an equation regarding Laplace transform and make it easier for them to calculate without taking a long time. For the next slide, it is about proposal elements. It has 6 elements altogether, which includes analysis, design, code implementation, program testing, program documentation, and also operation maintenance. For the analysis, gathering data and discuss the purpose of the conducted project. So we gather the data all about the Laplace transform and find the purpose. For the design, use both pseudocode and flowchart to propose the design stage because pseudocode and flowchart is an informal way to do the programming description that do not require any strict programming language. And for the coding implementation, use the Python program to do the project data because it can create the software of Laplace transform prototype and also it can develop a data or web of the Laplace transform. For program testing, test the program coding, whether it runs properly or not, and analyze if there any error occur on the program. The coding we have created may have some errors or wrong so that we can recreate or redo it again if it's wrong. Next, program documentation. Documentary on how the program operates after conducted from the very first that includes purpose, flowchart, user manual, input and output of the program, so that we remember and know all about the process how to done the Laplace transform coding. Last but not least, operation maintenance. If there are any errors on the program, it should be corrected and adding some improvement on it like user-friendly, so that many people will find it easier to use and they don't have any difficulties to use it. That's all from me, thank you. For the next slide, Celicia will present it.
Hi, I am Ceci Pinasakai and I will present about pseudocode. Pseudocode is an informal way of programming description that does not require any strict programming language syntax or underlying technologies considerations. It is used for creating an outline or a rough draft of a program. Pseudocode summarizes a program flows but exclude underlying details. This is our pseudocode, and we use pseudocode for sequential control structure, where we use start, declare, input, calculate, display, and end. Sequential control structure refers to the line-by-line executions by which statements are executed sequentially in the same order in which they appear in the program. As you can see here, we start the program. Then, declare the formula of Laplace transform. Then, we input some data into a Laplace transform formula to calculate the sum of Laplace transform to get the output which is displayed. And last, we need to end a program. That's all for pseudocode. Next, we move to the flowchart. As I said earlier, we use a sequential control structure, so our flowchart looks like this. First, we start. Then, declare calculator of Laplace transform. Next, enter the value of s. Next, enter value of t. Next, calculate the Laplace transform, and then sum the formula of Laplace transform. Then, display the sum of formula given, and then end the program. That's all from us. Thank you.